Welcome everyone. Uh, we would like to walk you through one of the experience, one of the implementations that we have recently done in terms using our Infosys Cloud Native platform, how it helps to accelerate the overall adoption for the utility major. Uh, Let me introduce myself quickly. My name is Ganesan Jayaraman. I'm an open source architect, enthusiast, a practitioner for last 10 years or so. Been working on the open source space end to end. Worked on the entire open source landscape end to end across the entire middleware dev stack. Mandar, you want to introduce yourself?
Hi, thanks, Ganeshan, and hello, everyone, wherever you are. My name is Mandar Shetty. I am part of the modernization and open source practice at Infosys. And as in my current role, my focus is on helping our global customers in their application modernization journeys with a focus on open source technologies. And part of those responsibilities also include building some of our platforms and IPs to accelerate and simplify these modernization journeys for clients.
Right. Let's look at the agenda. What we want to talk, what we want to discuss today. We want to start with business challenges and drivers, how the whole transformation journey started, what are the primary intention, what are the primary pain points, how we arrive the technology stack, why open source, what are the challenges in terms of the overall adoption of the cloud native journey, how the Infosys platform helps, and followed by a good demo. And then we are going to end up with lessons learned and some of the roadmap and next steps that we plan for the customer. Let me start with the problem statement. Who is our customer? So customer is a leading energy and utility provider and adopting a cloud native journey to modernize their existing infrastructure. The current landscape is primarily a monolith landscape. It is built which is built a very long back. It's completely based on the .NET and Oracle PL SQL based stored procedures, and the entire business logic and all those stuff is completely bundled into a single monolithic applications. They are primarily facing a lot of issues due to this monolithic landscape. The major issue is that scalability. They're not really able to scale. They're not able. As the business keeps acquiring the new businesses, acquiring competitions, they really wanted to expand the infrastructure, scale the infrastructure, that they are really struggling to do that. Not able to scale due to high demand. Because of the nature of the existing process, most of the changes taking a lot of time. The time to market is really struggling a lot. They're not able to innovate, not able to bring things faster to the market. Ideally, the monitoring and other aspects are really going for a toss. They're not able to detect where the issue is. It's primarily based on the individual's knowledge rather than the system or process. Most importantly, not able to take IT for their leverager to beat the competition, to meet the competition. They're not able to make it. They're really struggling. So they're looking forward to see if they can modernize the journey to move ahead of the competition. And from the customer perspective, they're also facing a lot of issues related to the customer experience. It's primarily because their front end and back end are tightly coupled. If the availability of the back end decides the customer experience a lot. If the back end goes down, they are not even able to read the data, which means the customers are not even able to browse the information on the website or mobile phone, which gives a kind of a bad customer experience for them, which is not something that they're really liking. And they're looking forward to kind of change those experiences as well. So these are the pretty much primary reasons why the customer is looking for a cloud transformation, cloud native journey from the existing landscape, from the current landscape. Yep, as I spoke about, the vision is that how we can break down the existing monolith 2-tier or 3-tier architecture to a distributed cloud native landscape where they will have a better control at the business level, at function level, will be able to scale, will be able to meet the business requirements, will be able to address some of the ongoing problems that they're currently facing. We spoke about some of the issues in the previous, in a while ago, and now this is the high-level view in terms of how they wanted to break down their existing monolith Oracle-based business logic and data structures into a microservices, a cloud-native microservices based solution where they would be able to leverage the cloud-native architecture to sort out their current problems. Some of the key features that they were looking forward would be that high availability of the environments, quick and easy to deploy. They wanted to automate as much as possible. Ideally, looking for a zero downtime canary release, AB kind of a testing and blue-green kind of a deployments to speed up the overall equation. They wanted to minimize the cost, avoid the vendor lock-in. They don't want to get into the particular cloud or a particular vendor, which the issues are something already faced. So we prefer more of an open source based solution, a cloud native, cloud neutral, which will be able to deploy across across clouds, will be able to leverage the hybrid cloud journey as well. So that's pretty much what that the customer wanted to achieve, and that is where their vision is. Well, it's quite interesting. The customer has just started the journey, and this is the first major cloud native implementation for them. So obviously, they want to be cautious. They wanted to make sure that they wanted to understand what type of challenges that they're going to foresee in the cloud native adoption. It's not something that you try to solve your previous problem and try to end up introducing a new set of problems. So it is better to foresee what are the issues that they're going to face, they're going to see in terms of the cloud native adoption in terms of before starting the journey. Primarily, technology evaluation and skills. And if you can look at it, the open source space, there are plenty of technologies, plenty of choices, plenty of options available. What is the right one to choose? Can I start with, I really love Redis. Can I start with Redis? Or I really like a particular technology. Can I start with that? Or rather, what is my business problem and what is the right technology to solve my problem? What is the right approach to take? Probably, that is one major consideration. And what type of skills required? They already face the problem due to dependency on the people. They have a lot of dependency on the existing people, SMEs and knowledge, that resides with a particular set of people. So if they leave, the knowledge also goes up. So they really wanted to see the technology is new, what is the right technology to choose, and how we can avoid the skill scarcity. Then the container ecosystem. The container ecosystem is quite complex. The reason is that they completely coming from the legacy world, adopted .NET and Oracle world to a cloud native world. So they really wanted to see, wanted to adopt what is a better way to sort of the container complexity and what are the things around it, how we can address this high availability and how we can ensure that the developers are able to start focusing only on the development rather than worrying about the new set of problems, new set of platforms. Distributed systems introduces a complex observability. You really need to monitor your end-to-end ecosystem. You need to have a proactive alerts. You need to ensure that your observability in place, and you will be able to achieve monitoring, tracing, auditing, logging, and that is what is required for your application to perform, application to measure, and give an alert proactively so that you would be able to know your issues ahead of the time. And really wanted to follow the DevSecOps process, wanted to follow the standards and ensure that it meets their governance and compliance requirements. And ideally wanted to avoid the cloud lock-ins, wanted to choose a solution that can deploy on any type of a cloud, that it can be portable on any type of cloud, and don't want to get into the specific cloud native solutions over here. Well, so these are the challenges we identified. We worked with the customer, we understood ahead of the time. Well, challenges are good. What about the solution? So our solution is we started adopting Infosys cloud native platform that address these challenges and help them to accelerate and simplify the overall cloud native journey. Well, how it addresses, we already spoke about these challenges. Now we try to introduce a platform which is going to simplify. This is a platform that you're going to see in detail. We're also planning to show you a demo as well for this platform. But just to give you the overview, the platform is trying to address all these major complex issues that we face so far. Primarily around, you can start the project in hours. You don't really need a whole lot of time. Everything is codified. You will have an automation template, self screens. You will be able to kind of self-service portals available where the developers will be able to start the project in hours. It completely abstracts your underlying, container platform, infrastructure platform, and try to give what the developers are looking for. And it helps you to create a custom dashboards in terms of monitoring, tracing, and all type of metrics can be captured, and it also triggers an alerts, which can be customizable, and we can adopt based on the requirement. It follows a standard DevSecOps process, industry standard DevSecOps process, and provide the customized, tailor-made templates based on the requirement to address the standards and governance and compliance requirements. Primarily, we are using open source standards. We wanted to ensure that we follow the open source compliance, open source standards, and at the same time make sure that code is fully open source. You don't get into the licensing issues. And ideally, wanted to avoid the complete cloud lock-in. So the platform gives the ability to start your projects in days, in hours, instead of weeks and months, and would be able to deploy across hybrid cloud platform or multi-cloud platform. So that's the kind of solution that we built. All right, we spoke a lot about how our platform addresses changes. But maybe this is the time to see what the platform is going to offer for us. Yeah, as I said, the platform is going to address, primarily on these areas. It helps on the evaluation. It does an environment provisioning. It helps to automate the application development. It also provides the observability and other type of utility services, and completely based on addresses this compliance and the security related requirements. There are certain screenshots in the attached to it, which is not quite visible, which you will be able to see a better picture during the demo. We'll cover a demo which kind of give you the flavor of what we are trying to do. Let me try to spend a little bit more time here just to give a overview in terms of how it helps you to arrive the overall architecture, how to choose the right product, and what type of cloud native features that are inbuilt within the platform, and what level of customization that we can do. All those things we can talk about a lot. So especially for this customer, we created the customized Couchbase templates. We created customized .NET Core based templates so that the customer will be able to start building the development not just on the Spring Boot. They can use .NET Core. They can use Node.js based on based on the technology that they're comfortable. And we also integrate with progressive web applications or single page applications using Angular, which help them to redesign their UI. And it comes up with a ready-made DevSecOps pipeline, which provides an end-to-end CI/CD journey along with security in mind. So we also customize some of the capabilities that the customer is looking for over and above what we have done. We also integrated with an AWS code commit, Cognito, and quite a few stuff because customer wanted to start with an AWS as a public cloud provider to start with. We'll cover more during the demo, but this platform is pretty much want to give you the an end-to-end view and helps to accelerate the overall development and overall cloud native adoption. That is what the customer has realized. All right, so this is the time to look at how the overall architecture looks like and what are the components we choose, what are the technology components that we choose. We spoke about, there are various components and how we ended up with a different set of things and how the overall, end architecture looks like. If you can look at it, it's primarily a hybrid cloud model where you have a private cloud managed by a hosting partner, and then we have a public cloud is on the AWS cloud platform. And we kind of come up with a hybrid cloud model to ensure that the legacy infrastructure, legacy applications will be able to talk to the cloud and will be able to talk to the digital layer or third-party partners and so on and so forth. If you can look at a little closer and the public cloud aspect, you can see a Infosys cloud native platform, which is a platform that we are talking about, which is added on top of the OpenShift platform to provide a seamless support to design and develop the end-to-end solutions, including a Spring Boot based microservices development or .NET Core development. It kind of provisions our Couchbase clusters in the backend. It also provides a complete customized dashboards for the logging, monitoring, and provides an end-to-end CI/CD platform. On top of that, you can see we kind of start building multiple business services, in this case, a billing service or payment service or appointment service, and so on and so forth. Different services built on different technologies. And to bridge the gap between the hybrid cloud and private cloud and public cloud, we started integrate with Kafka. We gone ahead with a streaming platform based on Apache Kafka, where we deployed Apache Kafka in both ends and replicate the data. We have multiple options, but we had chosen this primarily because of zero data loss, and we wanted to persist the data. We wanted to ensure that the new platform does not create data related issues, and will be able to retain the data at different intervals. So Kafka streaming platform acts as a bridge between our private cloud and public cloud, and moving the data back and forth. And then it kind of integrates with the complete backend solutions, backend databases. So we kind of come up with a holistic platform, completely open source based, cloud native, no vendor lock-in, can be deployed on any cloud, and will be able to leverage the benefits of the cloud native platform and meet the customer requirements. And Infosys cloud native platform added on top of it to ensure that the overall acceleration, overall adoption, has been accelerated the way that we expect. Well, we wanted to talk about particularly why we chose a different set of technologies, but we want to spend a little bit of time why Couchbase over other DBs. What are the primary constraints or criteria that we set? As we speak about, the customer is new to the journey. So they wanted to see, they wanted to reduce the operational complexity and wanted to see what is a better way to reduce it. Can I select a database that can act as in itself? By the time when we started this whole evaluation, we went ahead with the container technology, and we wanted to start with a database, a cloud native, high scale, cloud native microservices based, and a cloud native, cloud scale database that can support container technology out of the box. That is one of the primary criteria. And we are also looking for, we don't want to get into the master slave or minor major kind of an architecture. Rather wanted to focus on peer-to-peer architecture, primarily because of the scaling and sharding and other activities. And I also wanted to see a database itself can act as a cache at a certain extent. Don't want to choose a different technology for a caching, just for the reducing the overall overhead and maintenance, managing a different caching server altogether. Not only that, the cloud database is going to act as a operational data store for us, in terms of we'll store both the transactional data as well as the master data over here, and the data will be synced up with an Oracle database, which still acts as a golden image or golden copy at this point in time. So we wanted to ensure that the whole ecosystem being supported by good amount of out of the box components, out of the box plugins, so that we would be able to move the data seamlessly from Oracle to the cloud database with Kafka plugins and things like that. And we are also looking for, as I mentioned, we wanted to reduce the overall operational complexity. So we are looking for a kind of a capability in terms of automatic failover, scaling, and centralized management. Primarily an operator-based solution, which will simplify a whole lot of stuff. And Couchbase was a natural choice. That's primarily because they are one of the early adopters of the technology, operator technology, and introduced well ahead of the time. And they certified their solutions on OpenShift 3.11, which is our container platform of choice, has been chosen for the customer. So these are all the natural fitment for us. And then of course, the extended support offered by the Couchbase at the various levels to ensure that the solution goes properly, with the overall architecture and meets the requirements. All right, so let's look at a little bit more about Couchbase Operator, which is one of the primary reason why we have picked up Couchbase over any other solution. Some of the capabilities that we use today with Couchbase, Operator version 1.2. Why we added 1.2? Why not 2.2 for the latest one? That's primarily because we had started using a particular version of OpenShift. So we went again with the Operator version 1.2. Primary requirements are centralized management, Then we wanted to make sure that automatic failover capabilities. And if we wanted to do a cross data center replication, these are the capabilities that we use from the Couchbase operator. It supports out of the box. It helps us to provision the new cluster, with click of the button, and the configurations are pretty much simplified and centralized, and we would be able to achieve whatever the requirement that we have from our side. Couchbase Autonomous Operator does it very nicely, very bluntly, and then the latest versions have added additional features over and above what they used to provide in the past. All right, so we spoke about how the platform helps, maybe how the customer started the journey, and how the Infosys Cloud Native platform helped to accelerate the overall journey so far. Maybe this is the time to see something in action. I would request Mandar to walk through the platform, to show the demo of the platform, to talk about the features, to share the features to the audience.
Thanks, Ganeshan, and hi, everyone. We'll dive into the demo right away. So in the interest of time, we've recorded a video for you today. So what we're going to start off with is showing how we actually enter and create a project in the Infosys Cloud Native Development Platform. So this platform is part of the Infosys Modernization Suite, which is a collection of various Infosys platforms, tools, reusable components, all of which go towards accelerating and simplifying various modernization patterns for our customers. So in this case, I start off with creating a program with the Cloud Native Development Modernization pattern. And I get from there, I actually define all the steps in the pattern, and I get into creating a project. So this is, I've created a sample project in the Cloud Native Development Platform. The first step of the project is to define the architecture and technology stack for the applications. Now, here we support all Kubernetes variants essentially. So you can see over here we have Red Hat OpenShift, Kubernetes, that is the community Kubernetes, and various native cloud managed Kubernetes. So this is a platform which basically sits on top of any of these Kubernetes versions. It does not replace them, but it uses the underlying capability of Kubernetes and adds a layer of acceleration and simplification for developers on top of that. So in this case, I'm choosing Red Hat OpenShift. I next choose, I've selected, I want to create a UI as well. So I choose my UI technology. And then finally, I choose my microservice technology. So in this case, I'm choosing Java and Spring Boot, but this is completely, it supports various languages, various frameworks, all customizable and configurable. The next step for me is actually selecting the architecture for my project. Now, here what we have is a curated stack with what we see are the leading technologies and primarily open source based in this space. So you can see, for example, you can select various layers starting from your security, your API gateway, databases, caching, various kinds of middleware, messaging. Observability is something which we give as a default tool set using EFK, Grafana, Jaeger, again customizable. So all of this is a very pluggable tool set, because when we get into any engagement or any implementation for any organization, there is always an element of new integrations, new customizations. So it is built in a way that is very pluggable and extensible without too much effort and time. So the next step, I actually define what are my environments. So I can define the number of environments in each category. As you can say, you can define as many environments as you want. After that, my next step is actually going to be, once I've defined the architecture, my next step is going to be saving the architecture, moving on to provisioning of the environments. And now, in this case, we are going to provision an environment, provisioning the dev environment as we saw earlier. If you already have an environment and if you want to connect to an existing software stack, then the provisioning is optional. You can skip forward from that. So here you can see that we had shown the dev environment earlier. So in this case, I'm going to just give the connection parameters to the dev environment, the OpenShift cluster. What we get into next is actually the subscription sizing and the parameter configuration for the software. So whichever software is size subscriptions are sized according to resources. We use that subscription sizing to actually limit the software resources at this stage. For example, all enterprise software or all enterprise open source software, or most of them at least, really don't have a license key concept. So they are pretty much open, and your compliance to the subscription that you purchase is essentially a trust based system. So how do administrators actually control and ensure that what how much have I actually purchased? Am I deploying only to the extent of subscriptions that I've purchased? So in this case, for example, for Couchbase, um, I can actually see, when I say I can see a Couchbase has subscriptions in two sizes, CM and CS on Kubernetes. I can actually see that I have 8 available units, and I say that, okay, I want 3. So essentially, I want 3 nodes of Couchbase, and I see that is available. The system tells me that, okay, you can go ahead. I also go and validate and see whether I have the required infrastructure for actually provisioning that. And the system tells me, yes, okay, all the infrastructure on your OpenShift cluster is available for this size. And I next get into the software configuration. Now, this we are doing for all the softwares that we have defined. Now, this is something where typically every software has its own way of configuration of configuring its various parameters. For example, in the case of Couchbase, you have really dozens and dozens of various parameters related to sizing, related to storage, related to um, the compute resources, related to what kind of services are going to be there on that. Now, all of that's doing all this for in this case Couchbase or any other software, going into the individual configuration files, their YAML files requires a lot of knowledge of the underlying platform, a lot of time to do it, and of course, not to mention the chance of actually making a mistake while you're doing it. So what we are doing over here is giving a very simple way of configuring the key parameters for your software. So in this case, for Couchbase, I see I have an option to actually upload a configuration file. I can download a template, which is not shown here, but you can, the template comes with default values. And then I can actually make modifications in those values, upload the template. So here, the developer or the architect who's provisioning this environment has to really worry about configuring the key parameters for Couchbase, not worry about the other multitude of parameters which usually are standard, which you can of course go back and change it later if you want. But here you're focusing on the key ones. For example, you talk about which services you want, what are the buckets you want. So all of this is configured over here in a very simple way. In the similar configurations are done for all the software in each environment that you choose. At the end of this, basically, through a very simplified workflow that you have seen so far, and this is literally a matter of minutes, that you're actually able to provision all the software that you had selected, which typically, considering the skills required, the complexity is can take several weeks, is what we have seen in our client engagements to do without such an automation. Now, once so you can see, as you saw, the Couchbase cluster was deployed, and as you can see, you have it running on OpenShift. You can see just we go to the Couchbase console, we can see it's up and running. We can go and see, we deployed a 3-node cluster, so you can see all the 3 nodes up and running over here, along with the 2 buckets that we had defined. Both those buckets are also created. Now, next step is to actually define the DevSecOps tool set for my project. Now, this here again, we give a curated tool set with pretty much standard stages, which is again configurable or configurable to actually use existing enterprise DevOps pipelines as well. So here you can see we have, we're using a Jenkins server. We have support for other technologies like Tecton as well. You have various tools that you have defined for code analysis, code coverage, testing, etc. And your again, with a few clicks, essentially your DevSecOps toolset is deployed in the environments that we had configured. And now at the end of this, your environments are basically ready to start your development. So your developers now can start creating the projects and start developing. The first step that we saw, because we selected a UI technology as well over here, the platform comes with a a bunch of UI templates and components that developers can use. Essentially, all of these templates and components have come along with sample backend code as well to essentially bootstrap your UI creation in a very quick way. So once you have selected your UI components, they are actually checked in into the source code repository. The next step that we go to now is actually developing your microservice. We saw that we had our environment ready, we had selected our UI components. Now for creating your microservices, we have various options to generate the services from. So you can actually either create your services from database entities, you can create it from JSON specification, JSON based entities, or you can use a Swagger Open API specification. So in this case, we're going to connect to the Couchbase database that we just provisioned and generate the entities, generate the microservices based on the two buckets, the two entities that we created there. As you can see, we have just provided the connection URLs. We go to the platform actually parses the Couchbase database, sees which are the entities in there. I have selected both of them, builds and customers. I want to create two microservices, say. Now, what is happening in all the next few steps is basically we are taking out all the effort and all the non-functional code that a developer needs to write while creating microservices. So here you can see we have defined a couple of microservices, billing service and customer service. Now for each of them, again, within a very few clicks, I can actually generate my standard CRUD operations. I can add any custom methods that I want to add for those services. Um, uh, you will also get out of the box binding the out of the box code with binding to all the layers of the software that you define, all the dependencies, for example, logging, monitoring, tracing. All of those things are coming out of the box here. You can create your custom classes. You can add custom methods, as I said earlier, and you can also define finally how your microservices will communicate with each other. Now, here I can define, we have two services. I'm going to define a couple of communication methods. I'm saying, so the billing service get is going to communicate with, is going to call the customer service get. I can define the type of communication invocation is going to be synchronous or asynchronous. I can add multiple relationships within as many microservices and as many methods as I want. So all of this is going to get generated into the is going to be part of the code that we generate. And finally, I will go ahead. I can configure the security, the how microservices will communicate with each other. So we have methods for, you have either JWT or you have username, password, etc. Multiple methods can be configured. And finally, I see which are the services that I have. I can actually add other application and platform service dependencies. If you're using any custom libraries, custom jars, etc., can be added over here. And finally, at the end of this, my microservices code is actually generated and checked into the source code repository. As a next step, I just select whether I want a pipeline for all of them. I say I want a pipeline for all of them, and literally again within a few clicks, all my scaffolding code for the service has been created. For example, as you can, we are showing some examples over here. Um, you see the controller class, which shows actually the service to service communication, the two service communication between the billing service and customer service that we showed earlier. That is coming into the code over here. We also have the model class for Couchbase in this case, or it could be for any other software that we require. We have the Spring repository class, which actually has all the CRUD operations. So all of this, essentially what it's doing is, and there's a bunch of other code which gets generated, which has all the dependencies added for your for the logging, monitoring, tracing, as I said, which means the dependencies for the likes of Prometheus, um, Jaeger, the standard logging that we need to do in order to see the logs in Kibana. All of that is coming out of the box from the code. So and you can see we created a pipeline. your code, all the stages are actually executed. We are using OpenShift Jenkins pipelines in this case. So quite literally within a matter of possibly minutes, your all your scaffolding code is generated, and your developer doesn't need to focus on doing anything else apart from actually writing the business logic of the code. All the underlying complications, all the underlying uh, non-functional code is actually abstracted. Now coming to let's have a look at the observability dashboards. Now observability again in the microservice world is complex. There are a lot of moving parts, a lot of inter-service communication. So it's important to give a very simple user-friendly interface for both developers as well as administrators to be able to view the logs. So in this case, you can see the Kibana dashboard in which we have segregated logs by microservices, by various software components. Here on the screen, you are seeing the, the Couchbase logs, for example. So developers or administrators can easily get into the required service logs or required software logs. Again, you have that all the traces going to Jaeger automatically through the code that we generate. It's part of the code as well as part of the deployment YAMLs that we create. So you can see, for example, you can see the tracing from customer service to billing service, certain calls going, all of which is very useful for actually debugging any issues between complex microservice communications. Then finally, we have the Grafana dashboard, again, in which we have microservice metrics as well as the cluster metrics. So again, users can actually go and see the metrics only for the microservices that they want to see, where all of them are actually aggregated and showed in a very custom view with all the required metrics. Or you can go and see the cluster metrics which come out of the box in the case of OpenShift, which come out of the box through as part of the Grafana dashboards, which you are seeing over here. So all of this essentially, there are various other tools which are there which do this, but what we wanted to do was actually give all this monitoring, logging, tracing out of the box in a very simple way using an open source tool set. So you don't have to really worry about, even if you have other enterprise monitoring logging tools, your developers can actually start using these tools even in their developer environments in a very fast way. So finally, what we will get to is the admin module of the platform. So what we started off earlier was actually we started off provisioning our software on a existing OpenShift cluster. So what we will do here is how we can actually create that OpenShift cluster. So again, here we provide a simple way of creating OpenShift or any Kubernetes clusters. Now, depending on the how we do it under the hood depends on whether we are choosing an OpenShift or a Kubernetes or an AKS or an EKS. So in this case, as you can see, we are trying to implement or to install an OpenShift cluster on AWS. You just need your AWS subscription details. You give some parameters for your OpenShift, and your cluster will be up and running very quickly. So again, a very useful tool to get your project environments up and running in quick time without having to worry about, say, an infrastructure team or a central team to do things. I touched upon earlier the usage of subscription management and why it is important. So this, as part of the admin module, you can actually also we track and maintain what are all the various enterprise open source subscriptions that have been purchased in the organization or are available for this project. How many of them actually have been consumed? How many of them, you can see, we have different subscriptions of different types, each with different expiry dates, validity dates, and we can of course keep adding new subscriptions as you purchase them. And very importantly, we actually use operator metering, which is a fairly new feature to actually track the real-time usage of for that particular product. For example, through operator metering, we can say that even if I installed, say, 3 nodes of CM, as you saw earlier, am I actually using the same amount of resources, or have I scaled out in some way? Now, that could be for any software. For example, have I started actually using more resources, way more resources than I needed, that I planned for, which could be a non-compliance from a subscription perspective. So I can actually figure out what I'm using in real time versus what was allocated. So what you are seeing here is a very high level view. Under the hood, the operator meeting is giving us a real time view. So that's all I had, folks, in the demo. So thanks all. I hope it was interesting, and it's back to you, Ganeshan.
All right, Mandar. It's a nice demo. Thanks for it. I think it's fabulous one. I hope the audience really enjoyed it. Would be able to see the values out of it. All right, let me try to wrap up. What are the benefits achieved, benefits realized, and what are the next steps from mine. The benefits realized from the platform. So we are helping the customers to accelerate the overall journey. All the new projects we are able to see, we are able to kind of get up to 50% reduction in the overall development time to onboard a new application. So once the initial setup is done, all the new applications, all the new projects, new applications are kind of just started in, the overall development has happened just, flashing of time. We are really able to, save a lot of development time, able to spin off the environments, in a click of a button. We are able to choose the right sort of technology stack. Everything is, as you have seen in the demo, all the, DevSecOps pipeline and everything is fully integrated. The boilerplate code is ready, and then the customers are just going to, the development team is just going to start the development. The overall environment provisioning, we don't need to worry about dev, test, pre-prod, prod, all type of stuff. It just happens in days, not necessarily as you spend time on weeks or months. Fully integrated pipeline that you already see, and we have completely enabled the factory model so that it helps to, on top, it helps to accelerate the subsequent development and all the newer developments. From the realization perspective, the key issues is related to cost. Yeah, we reduce the cost. Deployment speed, wanted to increase the speed, deploy the speed, introduce automation, which we have done. Now we have a auto scale, scalable platform which can scale kind of any type of a load, which can be further scaled as needed, and it can kind of decouple your UI with the backend and introduce a complete, introduce complete, decoupling aspect so that your customer experience is improved a lot, and it follows the complete security standards and provides the, the kind of a high availability the customer is looking for. Let me wrap up with the overall session, with some of the lessons learned and some of the things that we wanted to do as a next step. We went ahead with architecture first approach. The reason why I'm talking about is that there are multiple technologies of choice before you choose the right one to go with. Well, how do you which technology to choose? And if you pick up microservices, then there are multiple choices. So instead of a technology-based or component-based approach, we decided with an architecture first approach so that it addresses the customer problems and then choose the right technology to enable the architecture, execute the architecture. And do the POC. We did a POC in 2 weeks and able to prove the overall stuff, and the customer really liked it because it's one of the, remember that this is the first journey, first cloud automation journey, modernization journey the customer is starting with. So seeing is believing. So we really did a quick POC and proved it. And we really recommend to do a performance testing as early as possible whenever your production like environment is ready. The primary reason is that when you start doing initial budgetary estimates, you go ahead with some ballpark estimates and you come up with a capacity planning and you start building something. But if you want to ensure that what you build, what you pay, what you have sufficient enough to handle your workloads, do the performance testing as early as possible. And again, a couple of points related to Couchbase operators. As you mentioned, Couchbase is one of the early adopters of the Kubernetes operator related technology. You have every version comes up with lots and lots of features. So you have to see what is the right version for you and what is a supported container platform for the version so that you'll be getting the maximum benefits. Of course, you have to plan DR for the manual scenarios to avoid the last minute changes, primarily because you are in hybrid cloud and you are choosing an operator, you are looking for a solution across the cloud. So make sure that you prove your customer that the data is not getting lost. You are safe. And last thing to say that work with the Couchbase team at all the intervals. Jokes apart, but it's a important thing. The reason is that when you introduce a newer technology, it is important to work with an engineering team as close as possible so that you will be able to figure out issues or sort out the problems ahead of the time. Very quickly, our next steps. Maybe we are just planning to have complete 3 availability zone, and also trying to evaluate Couchbase Cloud as a database as a service. Because when we started this project, Couchbase Cloud was recently emerged. It was not there in the beginning, or not there a couple of years before. Now, as customer is more looking towards reducing operational complexity, why not Couchbase Cloud? And it helps us to go for a consumption-based model as well. And it also helps you to kind of explore the new features as much as possible. And that's it. I think, hope you like the session. You have some takeaways from it. And if you have further questions, if you want to reach out to us, you can reach out to us, OpenShift at infosys.com. Thank you, everyone. Thanks for your time. Good luck. Bye.